negative 7x there we go. Get back in okay into the room here. Was it the audio that was cutting out on you? Okay, but we're good now with audio. Sweet, sweet. All right, not a problem. Okay, so in a problem like this, to figure this out, we said you have to find f of negative x. What does that mean? All x's get replaced with parentheses and a negative x inside. So this will look like a negative 7. X becomes this, parentheses with a negative x. And now you simplify this. Let's see. Negative and negative will make this positive 7x. So this is your starting point. You need this in order to compare whether or not the function is even. If it's not even, compare to see if it's odd. If it's not even and it's not odd, then you say it's neither. So you need to compare this. First, compare to the original function. What are you asking? Well, you're asking, is f of x equal to f of negative x? Question mark. Go ahead and replace these. F of x, you know, was negative 7x. On the right-hand side, you're going to replace it with what you just got. It was a 7x. That's what we just got for the other. So just emphasizing color here, I should circle it and put it in black probably, just so it kind of jumps out with the same amount of oomph. All right, and now the question is the f of negative x on the right-hand side equivalent to the original f of x on the left-hand side? Well, the answer, pretty obvious, is a screaming and in bright red. No, those definitely aren't the same. What does no mean? It means that it is definitely not even. If it's not even, great, don't panic. We move on. Where do we move to? If it's not even, we say, well, maybe it's odd. To check it, what do? We make a comparison again. So this time, though, we compare to the negated original function. All right, so let's see, taking a moment here. If we negate the original function, it would look like negative 7x, which gives us 7x. Now, there's something special about this notationally. This is notationally negative f of x. That's what it is. So let's go back and kind of pose the same type of question we did before. Now this time, is the negated original the same as f of negative x? I just want you to be real comfortable with the nomenclature here that's used in a sense. So what are we saying is basically on the left side, it's 7x. Where is this one coming from? This 7x is coming from right here. It's this line that generated that 7x. Is that equivalent to 7x? Oh, careful. That 7x is not coming from the blue. It's coming from what we generated over here. So this part boiled into this one, while the left-hand side came from the blue asterisk stuff that we worked. And now we ask, are these the same? And I think that's pretty apparent. We would say, yes, those are exactly the same. What does that tell us? It tells us that the function must be an odd function. Yeah. Any questions about that one? The method is the same every time. Try to see if it's even. If it's not, try to see if it's odd. If it's not, then it's neither even nor odd. Yeah. Let's do a few more of these problems. So again, this is even, odd, or neither symbolically. Let's start with f of x is equal to 3x squared minus 1. All right, start with step number 1, get f of negative x. Replacing here all x's with parentheses, -1 going inside, and then try to reduce this down. Let's see. This is going to square the 1. That's going to make it a positive 1. Positive 1 times 3 will be, or not 1, it's an x. Go figure. My brain is working in overdrive. And it's going nowhere. Okay, so squaring a negative, that's it. Squaring a negative is the same thing as making it positive. Oh, well, that's nice. Step number 2. Compare with the original. So notationally, is the original f of x equal to f of negative x? And you can see, without me even writing it down, the original was 3x squared minus 1. F of negative x, we just got it from step 1, was 3x squared minus 1. Oh, well, those are the same. Since those are the same, we already can say it's the same as the original, which means it's even. That was nice. It didn't even take as much work as the first one we did. These aren't that bad. These are really not too terribly bad. They can get tricky, but most of them are not crazy. But didn't you square the negative x? Excellent question. Squaring the negative x, what happened? Here's the thing. Some spots, especially that are confusing for people when they first start working these, negative x squared versus negative x squared. This is a confusing issue for a lot of people. What this one means on the left, it means negative x times negative x. That's the definition of squaring. Multiply by itself. Well, if you do this, what you're allowed to do is rewrite this. Yeah, that's what's coming. Yep, you can see it. So when you rewrite it, negative and negative will make it positive, and an x times an x makes it x squared, but that's really the same as just writing x squared. Whereas the other case, the major difference is this. The squaring on this one doesn't affect the negative. If you broke it down like we did in line 2, that's the equivalent of a negative in front of an x times an x. So what that ends up reducing to is still just negative x squared. Subtle difference, but enough to throw us off. Yeah. Does that help understand the difference there between those? Yeah, great. Great. All right, we've got a few more here that we're going to try to do, and that'll wrap us up for